Announcements on Thursday, which will be a day 1 for us. So this Thursday, we're going to be having our very first face-to-face Zoom conference call, okay? So the whole class should be chiming in. I don't know how many of you guys will wake up in the morning, but you should. We are supposed to have our Zoom video time at our regular class time on a day 1, which turns out to be 8:05 a.m. Okay, before you freak out, I'm going to push this back a little bit to 8:30 a.m. instead. So we will meet at 8:30 a.m. Our first Zoom meeting should be anywhere between about 20 to 30 minutes at most, which will run into your regular pack time. So it shouldn't conflict with your other classes' Zoom meetings. So on Thursday morning, I will be posting on our class web pages a link for you to click on to go to Zoom, and then you'll be able to just download a really quick launcher and then have a video of yourself kind of in with the class. So we'll try that out on Thursday, okay? Hi grade 10s. Okay, our lesson today is on solving polynomial equations. So just like we have in the past, anytime we say we actually solve for an equation, we want to solve for what is x. Oh, that is really big. We want to find out what x actually equals to. So you can follow this on page 377 in your workbook. It's going to be a short lesson. I wanted you guys to settle into the idea of how we solve for x and get some practice first, and then we're going to split this enrichment lesson into 2 parts, okay? So this will be our part 1 today. So if we were to have x minus 3 equals 0, okay, so in factoring, we always worked with just x minus 3, and that itself was a factor of something. But now we actually have an equal sign for the first time where it has a value on the other side, and that's 0. If x minus 3 equals 0, then what's 3? What's x? Well, 1, I just said the answer. 2, you already know. X has to equal positive 3. That's the only way this works. And if I had x plus 1 equals 0, well, this is only true if x equals minus 1. So in my factoring, if I had x minus 3 times x plus 1, and I tell you that this equals to 0, this is only true if this term right here, x minus 3 equals 0, so it would be 0 times x plus 1, whatever that number is. That could give me 0. Or if x plus 1 was equal to 0, then I could have x minus 3 times 0, and that would give me 0. Okay? So given that's the case, then that means x must equal to, if x minus 3 equals 0, then x equals to 3, or x equals to minus 1. We don't know which term turns out to be 0. Those are the 2 possible values of x. So in solving for polynomial equations, we rewrite this as x equals 3. X equals minus 1. I want to write my smaller value on the left-hand side, comma 3. Those are 2 possible values of x. And if I had another number in front, another factor that is just a number, no variables, 4 times x minus 3, x plus 1 equals 0. Does this change my values of x? It doesn't, because still I'm looking for the same thing. If x minus 3 was my 0 term here, then it has to be 4 times 0 times x plus 1 in order for this to be true. And if that were the case, then x equals positive 3. Or if x plus 1 was my 0 term, then I have 4 times x minus 3 times 0 equals 0, and I would have x equals minus 1. So this doesn't change the value of my terms. X still equals to minus 1, comma 3. Okay? So now we kind of have this figured out in terms of how an equation can give us 0 and how that x value comes about. Let's try actually solving for one of the trinomial equations that we've seen more frequently. This is what you have seen in the past, x squared minus 9x plus 20, and that's it, and you would have had to factor that. The difference this time is we actually have equals 0. We know that there is nothing on the other side of this equation, and that's when you can solve for x, okay? So let's factor it as we did before. 20 is 4 times 5, and I can make both of those negatives to give me a positive here and a negative here. So I split that into x minus 4 and x minus 5 equals 0. Using the same logic we did earlier, in order for x minus 4 to equal 0, then x has to equal positive 4. And in order for x minus 5 to equal 0, x has to equal positive 5. So we can sum it up to say that in x squared minus 9x plus 20, x equals 4 or x equals 5. In other words, x equals 4 comma 5. So if you have a graphing calculator, you can actually put this right here into your equation on the graphing part, and a graph will come out where you can see the value of x as 4 or 5. I'll show you guys here online. I'm using an online website called Desmos. I'll write this here. If you don't have a graphing calculator or is at home, you can use desmos.com. And what I've done here is just type in our equation x squared minus 9x plus 20 equals 0. And you can see here where my line, so this red one, I'll show you when I type it in so you can see, okay, x squared looks like this, minus 9x plus 20. So the red part is my line, okay? So already I have that equals 0. There we go. So right away here you can see my red line crosses the x-axis at the point 4, 0 and at the point 5, 0. Okay, so it just confirms that the value of x has to equal 4 or 5 in my equation. So it actually crosses at both points. So we write it as 4 comma 5. So let's try a few other equations here. This is also just a great review for us, okay? So let's look at A is x squared minus 81 equals 0. So this time we're actually solving for a difference of squares. In our equation, x has to equal, in the first part, a positive 9 in order for that to be 0. In our second factor here, x has to equal a negative 9 in order for that to be 0. So our answer is x equals minus 9 and positive 9. We can try graphing that here to see what it looks like visually. Minus 81, there we go. So you can see here on, this is a really long parabola. On one end we have minus 9, 0, and on the other end we have positive 9, 0. Those are the two possible values of x if x minus 81 equals 0. So when you put in a 0, it just gives us the straight value of x. Without putting in a 0, it gives us a graphing parabola. But you don't know that it is 0 on the other hand. You can assume that. And I'll try an example with that in a second here, okay? All right, so take a moment, pause the video to try out the other questions. And I will show the answers to the other questions in 3, 2, and 1. Okay, not answers per se, but this is a start. So let's look at B here. We factor that out and we get x squared minus 3 times x squared plus 3. We have another difference of square, but this time you have to be very careful, okay? So let's see, 2x minus 3 equals 0. If I want that to equal 0, then x equals, I move 3 to the other side, 3 divided by 2. So here I do have a terminating decimal, so I'm going to write it as that, x equals 1.5. X equals 1.5 in my first factor, and I don't even have to calculate it to know that x equals minus 1.5 in the other one, because in the other factor I have a positive sign, in the first factor I have a minus sign. If you do a few of these, you'll figure out a pattern really quickly that maybe you don't even have to go through all this step. If you have a minus sign within your factor here, then it has to be a positive sign in front of your value for x. If you have a positive sign, then it has to be a minus sign for your value of x, okay? So you can see that pattern kind of all across. All right, so our value of x here, x equals minus 1.5 and positive 1.5. If you have a repeating decimal, then you can keep your answer as a fraction, okay? So for example, if this was a repeating decimal, then you can write x equals minus 3 over 2 and x equals positive 3 over 2. But because it's a terminating decimal and just such a short decimal, please write it out in this format instead. Okay? Alright, so let's solve for the next one here. We have 10x squared minus 90x. The first thing we do, we factor out the 10x. And after you factor that out, you come to see there's not much math left to do. You're done. But let's solve for it. It's not just here that we have a value for x equals positive 9 in here, but we also have a value for x in our 10x, okay? In order for 10x to be 10, well then 10x to be 0, then x itself has to be 0. So we have two values for x here, x equals 0 and 9. Again, I'm going to graph this one out to show you what that looks like. So we have here 10x to the power of 2 minus 90x. Where's my graph? There we go. So my two values of x are 0, 0 and 9, 0. Okay. Alright, last example here. The first thing I want to do is factor out my 10. So now I have a perfect square, or sorry, not perfect square. I have a difference of square. 10 equals x minus 3. X plus 3 equals 0. X equals minus 3, positive 3, and I have the minus 3 from positive 3, x plus 3, and I have the x minus 3 giving me a positive 3. I'm just going to highlight that here. Okay? And x from 0. We can use this to solve more complicated equations as well, so let's do that for our first one. I can't factor anything out of 3x squared minus 13x minus 10, but what I can do, 3 times minus 10 gives me minus 30, so I need to find two factors. That gives me minus 13. but multiply to give me minus 30. Well, I could have minus 15 times 2 gives me minus 30, and they also add together to give me minus 13. Okay, so I'm going to rewrite that 3x squared equal, 3x squared minus 15x plus 2x minus 10 equals 0. I can factor that out, so I have 3x x minus 5 plus 2 times x minus 5 equals 0. So I have 3x plus 2 times x minus 5 equals 0. My two values for x, in 3x plus 2, x equals minus 2 over 3. And in x minus 5, x equals positive 5. Last but not least, I want to show you guys this one here. Pause this video and give it a try again, and I will give you the solution here. And there's the answer. Does something not look quite right? Okay, so this right here is a common mistake, because oftentimes when our last term is put on the other side of the equal sign, we forget that this is not the same as being equal to 0. Okay, so I'm going to leave that up here so to remind us not to make that kind of mistake, and we have to reorganize our equation first. It is 5x squared plus 30x, and I have to move this to the other side here. Plus 25 equals 0. Until my equation is actually equal to 0, I can't solve for x. Okay? Repeat after me. You cannot solve for x unless your equation equals to 0. So now we can solve for it as we normally would. Let's factor out our 5. Then we're left with x squared plus 6x plus 5 equals 0. 5 times x plus 1 times x plus 5. Those two would give us an 6x. Now we have x equals minus 5 from here, and x equals minus 1 from this term right here. Okay? So that's our final answer and all the questions we are going to do today. For your homework, I would like you to complete assignment questions just 1 to 4 for now. As per usual, all of them are assigned, but do them at your own discretion. So for example, if there are 9 questions, you can choose to do 6 of them if you feel very comfortable, but make sure you're referring your question back to the answers previously shown, okay? Before you guys go, I just want to show you guys an example of a really common error I've been seeing in your homework as I kind of go through and mark all of it. All of you guys should have homework submitted up to lesson 6. Okay, and if you don't have homework submitted up to lesson 6 yet, you're getting an email from me very soon, okay? So this is the common error where you have x to the power 4 minus 9x to the power of 2 plus 20. I know you know how to do this because I have seen correct answers from you guys, but I've also seen a lot of incorrect answers just due to carelessness. So we have x squared minus 4 and x squared minus 5. But you're not done. Okay, at this point, look for other things that you can still factor out. So we have x minus 2, x plus 2. This is factored out from our difference of squares. And then we have x squared minus 5. Okay, so that's your final form. And if you were to plug this into our into your Desmos calculator, you will see that if this equal to 0, then x equals minus 2 from here, x equals positive 2 from this factor, and x also equals to the positive and negative roots of 5. Okay, so you guys won't have to get into something like this for now, but it just shows that there are more than these two values of x's given here because the question is not quite complete yet, okay? All right, besides that, I also want to bring to your attention under your homework info for previous, for lesson 7, I have posted the solution here to number 12, and I've also posted a hint to number 13. I think from this point on, you should be able to solve for what x equals to, okay, and then also going back there using Pythagorean theorem to solve for what your lengths are. Okay, so give that a try. Let me know if you have any questions.